My name's Emily Chan. I'm the Director of Research Engagement here at the university, and I will be kind of your mistress of the ceremony. In terms of, if you're new to this event, let me kind of give you a few logistical components. We are recording today's events. There is an online audience, and they are listening to us. We will have a shared Q&A after all of the speakers have had a chance to present on their various topics. We will have questions from the in-person audience here. Please raise your hand for that questions. I will bring a mic to you so that those who are online may be able to hear the questions. Unfortunately, those who are online, we will not be taking questions from you. We're only taking questions from in-person attendees. And if you do need to leave, from those who are in the audience, please do so during some of the natural breaks between the presentations. And as always, please join us for lunch after the presentations and Q&A. So I'd like to welcome up to the podium Jessica Trask, our Interim Associate Vice President for Research, as she welcomes you all.
Thank you, Emily. So good morning, everyone. Thank you for being here. It is absolutely my pleasure to welcome you to the Research and Innovation Exchange Series and to see all the familiar faces from our researchers, our students, our partners from all around the Valley. So today we're going to be doing a deep dive into a subject that is absolutely foundational to the future of technology: artificial intelligence and semiconductors. These two fields are intrinsically linked. One drives the demand for unprecedented computing power, and the other provides the crucial infrastructure that makes that power a reality. The advancements that are being made in this field will shape virtually every global industry, and we are excited, and I'm personally excited, to be able to get to explore them with this group. What makes this event, though, and the work that's being presented truly special is a synergy that is unique to SJSU. It's the relationship between our incredibly innovative research being done by our faculty, the workforce-ready skills of our students, and the real-world guidance that we receive from our industry partners. And this is the relationship that allows us to ensure that the innovations that we develop at SJSU are not just theoretical, but are immediately applicable and relevant and deployable, both in Silicon Valley and beyond. So thank you all for coming today and for your enthusiasm. To officially kick off today's program, then, I would ask you to join me in welcoming Andrew Exner, the Executive Director of the SJSU Research Foundation, and also the Interim Director of the Office of Innovation and Corporate Partnerships. Thanks, Andrew.
Thanks, Jessica. You don't have to clap. I haven't said anything yet. You don't have to clap. Maybe it's for Jessica. Anyway, I'll be very quick. I just want to run through a quick overview because, you know, the event that we're having here today. Oh, thank you. The event we're having here today is really great in terms of internally kind of sharing some of the interesting research. We do these on different topical themes. Obviously, today is about AI and semiconductor, but at the same time, we want to invite the outside community outside of just faculty and students to experience what's happening here in terms of the research and the talents of our faculty and the research grants that we're working on. So we have some guests here today and want to increase kind of that presence in terms of, again, the commercialization and partnership opportunities that we have given our location in Silicon Valley and the relationships we have. So I'm just going to kind of really quickly overview some of those engagement opportunities. They include, obviously, industry-sponsored research. There are some times where we have industry partners that look to our technical and academic expertise and want to solve research problems, real-world problems, theoretical problems. And so sponsoring research through our infrastructure is one way. Obviously, corporate philanthropy. There's also a mechanism for donation and giving for certain aspects that support the university in different academic areas. From a workforce development standpoint, The Career Center has a lot of relationships also with corporate entities in Silicon Valley related to, again, the graduates and students that will be part of the workforce here in Silicon Valley at some point. PACE, this is another one, the professional and continuing education. There's also an opportunity in terms of engagement, much like Jessica mentioned, in terms of the guidance we get from industry on the type of work that we do. That also informs the type of education we can provide in terms of career development, upskilling, all the needs of the local community related to the education infrastructure that we have here at San Jose State. And lastly, senior projects and co-op programs. In the academic colleges, there are opportunities to engage in different academic areas. So these are some of the examples of ways that companies and industry can engage with our research faculty. This is a quick overview just to really show you that the actual research process is something that we manage all the time. My other job on the Research Foundation side, this is what we do day to day. And so we manage about $80 million of external funded programs through federal, state, local, and foundation grants related to all the research here at San Jose State. And the research kind of life cycle and grant life cycle is something that we manage. So in terms of trying to be easy to work with, in terms of how we actually, bring in money, manage money, operate grants, close out grants, report, all those sort of things is something that we do day to day, and we can make it very easy for our industry partners to work with us. We've done this before. We have a couple examples up here, but there are really good industry examples in all sorts of technical areas. This one focused obviously on quantum computing and semiconductors, but in the areas of autonomous driving, human systems interaction. There's lots of good examples where we have engaged companies. Wildfire research is another example where, again, we leverage our academic strengths to really try to solve real world problems. The other thing is that our new president, Dr. Cynthia Teniente Matson, is very focused on kind of being a catalyst for the local community, Silicon Valley and beyond. And so our growing partnerships with the companies that make San Jose home, that make Silicon Valley home, and the governmental interaction that we have to try to push this area as an AI hub is going to create and leverage a lot of opportunity, not only for our students, but for the companies that work here. Lastly, as part of the structure of what we do in innovation in the Office of Innovation, there is the industry partnership, and then there's also this idea of entrepreneurship. They're very closely linked in terms of the interest and needs of our students in terms of, commercializing technology through their own created companies. And so we also have an infrastructure related to startup and entrepreneurship that really does try to provide a full life cycle of support from ideation all the way to business startup to help all of the San Jose State community, staff, faculty, and students to also explore that avenue for technology commercialization. So that's the end of my presentation. I don't want to take up any more time before we get into the meat of the good stuff. Jason's here with us today also in the back. So if you're interested in kind of following up or hear something today that you'd like to hear more about, there's multiple ways for you to get a hold of us. And with that said, I'll pass it back to our mistress of the day to continue on with the program.
Thank you so much, Andrew. Thank you so much for sharing all of the ways to engage with the university. Thank you. Okay, well, now I have the absolute pleasure of introducing our keynote speaker, Bill Berry. He is CEO at Ignite GTM, an impactful partner for industry entities seeking to translate their technologies to marketability and commercial success. He's also a co-founder and partner at Infracore, providing AI infrastructure solutions to companies. We're so glad to have Bill here because last week he was over in San Francisco at the AI Infra Summit, where he shares insights on the state of AI infrastructure and some of the inputs and outputs of this really competitive sector. And he'll kind of help give us a lay of the land of what this all means, particularly here in the heart of Silicon Valley at SJSU. So without further ado, please let us all have a nice round of applause for Bill Berry as he comes to the podium. And may I add that he is a former Spartan. So woohoo!
Only then they clap.
No, not at all.
All right, you want me to stand
Sure,
here?
if you don't mind. And
Yeah.
then-
You gonna give me a timer?
Oh, yeah, we'll be your timer.
Okay.
And advancing, and then if you need the laser.
Got it. All right. Thank you so much, Emily. That's a fantastic introduction. My name is Bill Berry. As Emily mentioned, Ignite GTM, we're a go-to-market agency. We lead industry events like AI Infra Summit, which we had last week. That was our fourth one. So this presentation came out of there, and I just want to let you know that this is like what we pride ourselves on is that we're a for the builders, by the builders, right? And the reason why I framed this presentation is we don't know what's going on, meaning like there's so many layers that need to work together and there's not a lot of conversation, right? So we really are proud to be able to be a market connector and convener of these conversations. And then, we'll also explain why I'm so interested in making sure that we build this bridge back to San Jose State, yeah? So data centers, who's in AI now? Just checking hands. AI, okay. Who's in the software side of AI? Who's in the hardware side of AI? Okay, sir, you're straight through. Who's been in a data center? Oh, okay, one maybe. Okay, great. As you guys know, data centers are kind of the heartbeat engine. It's not just the GPUs. It's more importantly, we're past the GPU stage. Power is going to be the bottleneck. So let's just going to go through these market stats, and then I'm going to stick around for a few hours afterwards. So if you guys wanted to ask more questions and get a little bit deeper, we can, but I'm just going to go a little bit surface level so I can fit this in within the time, yeah? So here we go. So the engine that powers AI is infrastructure. And now infrastructure, you hear the news every day. I go to my parents' house and they for some reason, they're just watching CNBC as their retirement hobby. And every single time I see CNBC, I'm like, CoreWeave, Core Scientific, AI data centers, NVIDIA. This is the true crux, the battlefield of AI, right? And a lot of folks in certain contexts, you could take a look at it as an arms race between US and China, right? Because it's the fight for the rest of the world. We want to have most of the world use US AI, and then China has their aspirations, right? And then, so we are in a global arms race, right? And it's so prevalent that there's also national mandates that came out. Who here has read the AI action plan by the White House? Okay, there's a lot of good stuff there. That's the first time, at least in my lifetime, that I've seen something that comes out of the White House to kind of rally the industry together. There's a lot of great stuff here. A lot of it is about building data centers and then how fast can we build them? How can we remove the red tape? A lot of the other stuff, if you really drill down, there's stuff about workforce training. We should start as early as middle school, not high school, middle school. Let's start getting everybody AI native, AI competent, AI centric, right? So there's a lot of good stuff there. It's easy to find online. Please take a look at that. But just between US and China, 51% of the data centers is between those two countries. And then we're looking at more than double this in 2030. So we're building at a fast pace. AI-led automation can unlock 10 trillion in the next decade. This is kind of looking at the enterprise level. The reason why this is important, it's the canary in the coal mine for the builders, right? The data centers guys, we're building on 7-year cycles, right? You go up the stacks as a 3-year cycle. We need to know that there's still use cases. This is not a bubble for the builders because the builders will stop building, right? So taking a look at enterprise, and this is one thing that our summit is we try to bring in more enterprise clients, right? Because this is the buyer of infrastructure. And every single time enterprise confirms that there's an AI function that can make them more efficient, that function scales, and we need more infrastructure yesterday is always the conversation with enterprise, right? So 73% of enterprise CEO expect Gen AI to fundamentally transform their businesses, and then we do these road shows as well. We were in Chicago for AI for banks, retail, and then we do retail. We were in Atlanta for a retail presentation, and then we see the retail group really experimenting with how do we increase user experience, how do we reduce costs. Tariffs is was a big concern over there. On the bank side, they are creating implementation teams so they can implement faster. So this is an opportunity for startups to be able to get into enterprise because they are now, it's not this long due diligence process, right? But there's opportunities for innovative products to be able to get into the enterprise workflow right away. This is not a small market. This is a huge deal. $1 trillion backbone is what we like to talk about. So just in 2025 alone, $1 trillion have been invested into infrastructure. $7 trillion by 2030. That's a huge jump from, in 5 years, we're going to spend right? So the rate of spending is going to go up. 1.3 is going to be in real estate, 3.5 in GPUs. And for every single time a dollar is invested, it also creates $2 to $3 of additional adjacent value for other services, right? So when you take a look and project out, we have this McKinsey chart, 2040, right? Look at the, think about right now, $1 trillion, 2030, by $7 trillion by 2030. By 2040, how much are we spending? 106 trillion as a global, from a global lens. And if you take a look at remove transportation, take a look at energy and digital AI, that's really AI infrastructure together. So that number is 42, right? So huge jump. Massive amount of workforce is going to be absorbed by this space. A quick note about circular economies. You've heard you see the news. OpenAI, NVIDIA invests $300 billion in OpenAI. Next week, OpenAI agrees to a $300 billion project with Oracle. And then Oracle has now to go find the data centers and build it. But they're committing that they're going to spend most of that money back to NVIDIA, circular economy, right? There is a fantastic write-up about this, how this is more strategic than it is a Ponzi scheme, right? So we actually had Devansh, the author of this article, which I can share with you guys later, present on this. And it's just, this is talking about strategic alignment from a balance sheet level, right? Because once you were able to create that chain is unbreakable, and you can count the customer commitments, the revenue, and the business behind that. Lots of data center stats out there, but here's the real crux of the problem. 90% of them are not, of existing data centers cannot handle AI workloads. 100% of the data centers that can has been pre-leased at the end of 2024. Each data center requires 30 megawatts, but more importantly, the density, how much power can you bring down into a rack? That's the real bottleneck. Right now, traditional data centers are about 5 to 10 kW per rack. And then now for AI workloads, it's 40 kW, 250 kW. We have an InfraCore project that the customer is asking about 177 kW. And then we have NVIDIA talking about get ready for the megawatt racks, which is going to be really crazy from a density standpoint. But this is the crux of the problem with the data center. It's going to require a new era of builders. We talked about InfraCore. So being able to take existing property and existing progress and then being able to turn that into AI-ready inventory is really kind of what we do over there. So we have a large project in Tulsa and then also a data center in Chicago that we have in our portfolio in just 8 short months. True bottleneck is energy. We're going to run out of grid, period. It's just not possible. Right? And then so data centers will absorb 5% of global electricity by 2030. Grid approvals, utility guys, they're not used to working this fast. So a lot of they're like, we'll get back to you in a few months. We're like, no, we need answers today. Right? And that's kind of some of the delays in the supply chain. Rise of microgrids. I mean, by 2030, DOE says that we're going to have 200 gigawatts of behind the meter solutions to be able to keep up with AI data center power. Or then it's going to be starting making decisions like, are we going to power up this neighborhood or this data center, right? We don't want to get there. So behind the meter solutions is really going to be on the rise. I know I'm close on time, but this is the framing problem that we have for AI and for Summit. When we take a look at application and workloads, use cases, right? We had Spartan AI, right? These software agents can be created in weeks, right? And from the business side, when they have a use case, they will build that in weeks. And then the soft infrastructure between the GPU and the cloud needs to be built out to be able to support that. That's built in months. Hard infrastructure is built in years, right? So how do we reconcile all this? The answer is collaboration and AI Infra Summit. So that's I was setting up for that point. But that is the true collaboration that's needed at an industry scale. And then this is not even the biggest one. This wave right here is where we're calling from a cloud perspective, the training phase. And we're starting to get an inferencing, but inferencing is quietly around us. I'm sure on the way here today, you've seen inferencing in motion. Do you know where? Can anybody throw out something that you saw this morning that is inferencing in motion? EV cars, Tesla. If you saw a Tesla this morning, you saw inferencing in motion, right? And that's truly, the rule of inferencing is going to be more intelligence closer to the edge, always, right? So the car edge is the auto edge, and those GPUs and that compute is taking all that instance. We have self-driving cars in Waymo. They have to be 100% perfect, right? One accident, and that's way too much, and they'll throw them off. So we're saying that this phase, as big and crazy and as wild as it is not the biggest phase. Inferencing will be a 10 X. My thought is going to be a 10X play. Jensen said 100X. He might know more than me. So I guess the number is somewhere between 10 and 100X, but which is huge, right? So what this means, collaboration at scale, collaboration across the industry. How do we all these layers work together, from data centers to soft infra to application workloads, paying attention to what enterprise wants, and then being able to kind of reverse engineer that back requires a lot of conversation. But we need to build a bridge for the next generation of workforce. And that's why I'm so happy to be here. We want to make sure that we can take the learnings from the industry, build a bridge back, not only for the workforce, but work closely with the research organizations that you guys have here, right? If you guys want to test anything through us, we always invite you to our events. And then it's really important that we need to lean into where the talent pool of AI natives. This is the capital of Silicon Valley, okay? And this is one key point I'll close up. In my travels, I went to San Jose State. The other side of that story is I never finished my degree. I had to make a decision in 2004 that I'm just going to go all in and do work full time. And it was in advertising, right? And then shortly after, I got into data centers. But what I want to make sure is that we build a bridge to make sure that the students now can see the future. They can see the things that are being applied out there. And what does that translate to? An electrician here could also be a high voltage electrician inside a data center, right? And so working together with San Jose State would be great. And through all my travels from work, Silicon Valley is the shining city on the hill that the whole world looks up to. If it makes it here, it makes it anywhere from a tech standpoint. That was New York's phrase. That's our phrase from a tech standpoint, right? Oh yeah, but that, by the way, there's also San Jose. That's always the conversation. And it always bothers me as a San Jose native going, no, we are the capital of Silicon Valley. I drove by these signs that says we're the capital of Silicon Valley, right? But the point is, in this market shift, and what I want to tell everybody in this room, this is our time to bring San Jose State to the forefront, right? Because we are AI native. We are at the epicenter. We are the builders. If anything, if there's a brand of San Jose State, is that we're the yeoman's university, right? Flying under the radar. I think I heard some of it. It's now time for us to ascend and get to that next level, and I'm happy to be part of it. Thank you.
Thank you, Bill. That was terrific. And what a way to kick off today's presentations. So now I'm really excited to share today's presentations with you all. We're going to have 3 presentations. They're each going to be about 10 minutes apiece, and they're going to cover a variety of topics. So our very first presentation will be Spartan AI, Elevating Course Design with Faculty and Student-Centric AI Agent. This is headed up, we're going to have Dr. Wenson Wu as our first speaker with Pratik. And Dr. Wu is the Associate Professor in the Computer Engineering Department. She joined SJSU in 2018, has made significant strides in the areas of AI, robotics, and teaching and learning. So welcome. Thank you.
Thank you. Thank you very much for the introduction, and also thank you for inviting us to speak in this very impressive event. So I'm Wenson, so I'm an associate professor from the Computer Engineering Department, and Pratik, he's a graduate student in our department and also a research assistant working with us on our project, Spartan AI, Elevating Course Design with Faculty and Student-Centric AI Agent. So before the presentation, I'd like to give a little background of our project. So this project is sponsored by California Education Learning Lab AI Fast Challenge, and it's a 1.5 year project. And we have multiple PIs working on the project. On the SJSU side, we have the lead PI, Dr. Injie Liu. She's the Director of Digital Learning Strategies. And Dr. Magdalena Arinaki and I, we are co-PIs of this project. And we are also collaborating with Quality Matters team. We have Dr. Adele and Barbara Birch. And what is Quality Matter? So I'm sure many of you have heard about it and have been working with it. And Quality Matter is the national leader in quality assurance for online and blended learning. So they developed rubric-based standards used by over 1,300 institutions worldwide. And they have a network of 7,000 certified peer reviews. So the motivation of this project is from the observation that we found that as faculty, we're using a lot of online platforms such as Canvas, right? So we use Canvas to host our learning materials. And we found that faculty increasingly seek timely, personalized support to enhance the online course design. And given the fact that many institutions, they may have very limited number of instructional designers to help faculty. So we found that there is a growing need to explore innovative and AI-powered solutions that can provide scalable, just-in-time guidance for faculty. So given this motivation, we propose to develop this Spartan AI, which is a scalable AI-enabled solution, which could produce fast, secure, and customizable course content analysis, and it can also provide course design feedback based on student insights, innovative pedagogy, and instructional design principles. Also, it can produce equitable course design resources for institutions with fewer resources. So I would like to mention that this our Spartan AI was featured in 2025 EDU course Horizon report. So it came last month. Okay, so I'm gonna stop here and hand over to our student Pratik, because he is the one who is developing this this platform for us, and we do have other student assistants, and yeah, he's the one who is familiar with this one. Okay, so yeah, I'm hand over this to you. Thank you.
Hello everyone, my name is Pratik Korat and I work on the AI side of this project. So what is the problem statement? So throughout my time at SSUs, I've seen many courses. Some are like very aligned and some are like poorly aligned. So and today professors are increasingly motivated to improve the quality of design of their courses, right? And because of the QM's rubric evaluation is like very rigorous, and having expertise, it will take so much amount of training to improve their courses. So our goal throughout the Spartan AI is to develop an AI-powered tool which helps the faculty improve their courses. We want to simplify this design improvement process through the Spartan AI. And we also want to offer some actionable insight to faculty so they can improve their course. Okay, so what is the motivation? Like, think of a professor is preparing their courses for the next semesters, okay? And they always want to improve the quality or quality design of their courses, right? But having to access to this QM's evaluation rubric is very time consuming, and largely this process is very manual. So professor need to go each professor need to go through their courses line by line. They need to check their syllabus. They need to check their course level objectives, module level objectives, assignment, quizzes, everything against the QM's rubric, which is like very time consuming, and that is a repetitive task that we identified. And faculty spend significant amount of time improving their courses. So what if there exists a tool which we can delegate this task to that AI tool? So that's where the Spartan AI comes. I think that most of you are like aware of what is a canvas. So think of Spartan AI as a mini canvas, but enabled by the AI agent in the backend, which can understand your course, which can analyze your course, and which can also provide some actionable insight for your courses. Okay, so this is the workflow of the Spartan AI, that how it works. First, you export your course from the IMSSC format. Then you upload that course into our Spartan AI, and our AI analysis engine will analyze this course. It will prepare the course for the evaluation, and then comes the evaluation and the scoring of your courses. So think of this Spartan AI as an improvement tool for you, built for you. So yeah. And recently we also integrated the student feedback integration. So we are working to we are making sure that whatever the student feedback is received for the course, we are integrating that for the improvement. And at last, we will also export a report for your courses. So what can be improved, what can be changed to make it more student centric. And this is our working prototype. So we finished our working prototype in the last month, and now we are improving to make sure that it is scalable to so it is available to the student. So this will be the landing page, and this is one of the example of the courses where you have option to upload the courses, and this will be your landing page. So this is the example of the how AI analysis will. So in the QM's evaluation rubric, we have around 41 rubrics, and we need to check each and every rubrics against your courses, professor's courses. And this is the example of that how AI analysis evaluation will. So in the backend, this technology is powered by the LLM, and to avoid the hallucinations for the prediction for the generation, we will also provide some of the sources from where our analysis comes. So all the sources are from your courses. So that shows, and we also have justification like why is it your evaluation is happened that way, and we also provide some supporting evidence to make sure that you can locate where what is wrong in your course. And we also suggest some of the improvements so that you can improve the course. And this is the course map table. So you will be familiar with your course, like how your course is mapped throughout the canvas. And this is a student feedback form. So right now the working demo is available to the internal users. We are planning to make sure that it is available to faculties in the next few months. And our future goals is that we presented our demos to the QM's focus group, and we received some positive feedbacks. So we are currently working on integrating those QM feedback. And by end of this project, our goal is to expand this Spartan AI not only to the Canvas, but to our other learning management platform as well. And half knowledge is not always good, right? So we are also preparing some of the materials so that faculty can be introduced to these. How does the Spartan AI work? So once faculty knows how Spartan AI works, they will be familiar with the limitations, and it will be really beneficial for them. And we want to sustain this Spartan AI throughout the quality matters dissemination network, which has large access to the network and the industry. And this is the early sign-up form. So those who are interested in evaluating their courses or to analyze their courses, please sign up for this form. And those who are more interested, they can contact the Dr. Inji. So.
Thank you so much, Dr. Wu and Pratik, for that great presentation. So I hope you have collect your questions, and we'll have a shared Q&A after. So now I'd like to welcome to the podium Dr. Armin Mogadam. He is director of the manufacturing program here at SJSU. He's also he's an assistant professor in the aviation and technology department, and he joined SJSU in 2020. All right, round of applause. Thank you, Armin. And he's going to talk a little bit about semiconductors.
Okay, hello everyone. Thanks for joining us today here. I have no student with myself. I had 6 of them in my team. 5 of them graduated, 1 of them doing internship, so it's just me. Today I'm going to talk about mostly manufacturing, but specifically semiconductor manufacturing and how we can train models for a specific defect detection in manufacturing processes. Okay, so this is the project objective. My research area is computer vision and AI, but with a focus on manufacturing. And the whole goal is we want to make manufacturing cheaper, less expensive. And to do that, we need to incorporate AI and computer vision specifically for a specific task. Again, defect detection is what I'm focusing on at this point, but we have many, many different tasks that you can use AI and you can reduce the price of production. If you're familiar with AI, I assume that you're here, you're familiar with AI. You know that when you want to develop a model, you need to have a trained data set. The problem in manufacturing is we don't have training data set for every single parts that we are producing. So how can we solve this problem? We came up with the idea of using synthetic data. We came up with the idea synthetic data is not a new topic, is there, for many years, but with a specific focus on manufacturing is kind of new what we are doing. So synthetic data, if you're not familiar with that, is the data that is not real. So we generate that ourselves. We train the models on not real data. Amazingly, we just modified those not real data in the way that models, they can perform in real environments. That's the whole goal. So as you can see here, defect detection, synthetic data, and then testing the models on the real environment, see their performance. So how can we generate synthetic data? This is actually, I have two works to present today. This is the first one. We are actually going to present this one in IEEE conference in Florida in 2 weeks. So the idea here is this. We came up with this idea of using synthetic data, and we wanted to just try it somewhere to see if it works or not. How can we generate synthetic data first? So there are a bunch of game engines that you can design gaming, computer gaming in those. But the good thing about them is they have physics engines in them. It means that you can kind of simulate real world stuff. You can simulate the gravity. You can simulate the collision between two cars. And amazingly, they work very good. So we said that how about if we use this to develop our synthetic data? So it's kind of animation environment, but you can make it very real look like. So we use Blender. Which one is the laser? Okay, we use Blender. So we have two main ones. One of them is Unity, one of them is Blender. The good thing about Blender is behind the scene, you can do Python programming. You can manipulate the scene. You can design parts by just Python programming. So we used Blender. We came up with the just kind of example or the case study object, this cylinder that you can see here. We imported that into a scene, import some randomness into the scene, kind of changing illumination, camera angle, and the texture to make the parts and the scene more realistic. We did the automated labeling for those, and I will explain how shortly. We repeated this over and over again, and we generated thousands and thousands of different images for this part. And then we trained our model on those. So what we did was, this is, I'm not sure if this is visible or not because of the light. So this is what we have, we call it wireframe of a part or of an object in Blender. Then we came up with the idea that what kind of defect we can just impose on this object to see if, again, the whole idea for this project was to see if synthetic data works or not in manufacturing environment. We came up with the idea that, okay, how about we just impose some cracks on this object and train a model to detect those cracks to see if it is possible or not. So wireframe, we went to the object itself with the cracks. And if you can see on these cracks, we have some blue color. Because we generate these cracks ourselves randomly over the surface of the object, when you generate that, you know where they are. So the labeling process is going to be automated because I know already where the cracks are. So I'm changing the colors of that, and I'm using a mask to generate the label data. So at the end, again, repeating this loop over and over again, I was generating one image per loop, ultimately thousands of them. And we trained a model to do this crack detection. And here you can see that we 3D printed these objects with cracks on them. And these are the detections. And you see that we were trying to make the environment kind of hard for the model to see if it can detect it in the complicated environment. Different backgrounds and multiple objects in the scene. You see that, for example, this is the object. We have a bunch of cracks on that, and the model just detected all those cracks here. After we were done with this, we said that, okay, let's expand this one to the semiconductor manufacturing. And in semiconductor manufacturing, we have wafers that we use to generate chips. And one of the main defect using those wafers is the scratch that we have on those papers. I said that, okay, expanding the previous work to this one, we generated synthetic data, again, using Blender. This is kind of a mask for a wafer. probably you cannot see this, but there is a crack here with the blue line, because again, we know where the crack is. And this is the final wafer, and sorry, this is a scratch. And this is the scratch on the wafer. Again, the idea here is train the model to catch that scratch. And for the real environment, for the testing bed, we did this in my lab. So we came up with this box. As you can see here, there is a camera inside that. There is a wafer under this, and we have a bunch of LEDs to control the illumination of the environment. Anyways, we trained the model. We generated a data set, 4,000 images. We trained the model, and we tested that on the real environment that we had. This paper is actually under the review, so I'm not sharing all the results, but we trained a bunch of different models on that. And as you can see, it's performing quite good. So the precision and recall that we have for this model is above 95%, which is kind of acceptable. Again, depending on the manufacturing, they are going to define the acceptable. But for the research purpose, this is acceptable. And as you can see here, this is the confusion matrix that we have. And you see that this is the detections on the true or positive class is, most of them is happening here. And we have few mistakes here. And this is the training process and the performance of the model, measuring, again, the precision, recall, and mean average precision. As you can see here, when it goes up, means it's good. And these are some of the examples for the detection. So we had actually two models working together, one detecting if there is a wafer or no wafer, and one detecting a scratch on those wafers. As you can see, we are detecting all of them. Actually, I picked the good ones to put it here. We made some mistakes in some of them, but mostly we were performing good. And that's it.
Thank you so much, Armin. That was terrific. And again, please note your questions for the shared Q&A. Now I'd like to welcome to the podium Dr. Mohammed Massam. He's an assistant professor in the Applied Data Science Department. He joined SJSU in 2022, making a strong impact, not only in shaping kind of the graduate students' projects in the AI area within that department, but in involving his students with his research. He's going to present his project today with one of his students. So please welcome Dr. Mohammed Massam to the mic. Use the laser. This is the laser, and then this advances.
Perfect. Thank you, Emily, and I'm happy to be here, and thank you for inviting us to present the work. I'm happy because this is a student-faculty collaboration project, and with me today we have Sakib, one of my research student. So in today's project, this is a very interesting one where we wanted to make clinical notes more explainable. Here, the title is From Tokens to Terminologies, How Knowledge-Grounded AI Enhances Clinical Language Understanding. So why clinical test understanding matters, or why it is important. So around 80% of HR data resides in unstructured clinical notes, which is largely inaccessible to automated systems. And these narratives, meaning these clinical notes, capture essential information like symptoms, reasoning, clinical observations, and many more. However, for their free text format makes systematic extraction and analysis inherently difficult. So unlocking these clinical narratives enable trustworthy and knowledgeable grounded AI. So there are two main core challenges that we wanted to solve. One is entity recognition from the raw clinical notes. So the clinical notes is dense, inconsistent, and filled with shorthand. Even advanced transformer-based models, it gives some misclassification. Therefore, accurate named entity recognition is the foundation for structured clinical data, and our goal was to extract meaningful, more accurate medical entities from unstructured narratives. So here in the image, if you see in the left side, we have a raw clinical notes. Our goal is to extract the entities from the raw clinical notes. So this is the second challenge where we wanted to normalize the extracted entities because abbreviations or shorthand like SOB, it may carry multiple interpretations. For instance, SOB, it may tell you that, okay, this is shortness of breath. On the other hand, it can be side of bed. But for medical ontology systems, short of breath is more aligned with our task. So without normalization, the entire data will be fragmented and non-interoperable. Therefore, it requires knowledge-grounded reasoning that links terms to trusted ontologies. Our goal is to resolve this ambiguity and provide a more explainable, reasonable text to healthcare system. Therefore, the research objective is to build a unified clinical AI framework that combines both named entity recognition at the same time after we extract the data to make it more explainable system. So here we can see the entire system in terms of research objective. Given a clinical note, we will apply a named entity recognition system and it will extract all the needed information in a tabular format, more structured format. Once we have this structured format data, our goal is to normalize the entire data and make it more explainable. For instance, if you see the third column where we have CKD as disease disorder, which is an entity extracted from the model, the normalization process will make it chronic kidney disease, which is more explainable. So this is the proposed framework. There are two stages. One is named entity recognition. Another one is dictionary infused RAG. In the first stage, we fine-tuned the BART model and extracted the entities. Once we extract the entities, then we pass it through a RAG system. And here the RAG system is advanced RAG system. Initially, we extract the relevant k number of candidates using a regular semantic search. After that, we apply a re-ranking process, which we call composite re-ranking. Once we re-rank the retrieved documents, then we pass it through LLM systems to generate the normalized terms. So this is the composite re-ranking system that we proposed, where we integrated both semantic similarity and a lexical similarity using a weighted equation. And now I will hand over my mic to Sakib.
Thank you, Dr. Masu. So I'll carry on from here. So to know how the pipeline works, we need to look at the data behind it. So we use two data sets mainly to train our BERT model, which is Macrobat and AG Bonnet. These two data sets give a good reflection of how messy the EHR, which is electronic health records, can be. So we fine-tune our BERT model using these two databases. And the reason we use these two data sets is because they contain, they are annotated with entities like disease, symptom, test, and medication. And the normalization backbone, we use a unified medical language system. It serves as a medical knowledge base for RAG retrieval and normalization. And it provides a standardized medical vocabulary. So we populate our vector database, which is Pinecone, with the UMLS, which enables semantic linking and dictionary-driven lexical re-ranking through concept aliases and definitions. So the experimental setup, so we fine-tune the BERT model. These are the more technical terms, the learning rate, the batch size, how many epochs we train it for. Then the entities that is extracted, we embed them using the BioBot embeddings and Pinecone retrieval, where top K is 10. Finally, we normalize it even further using LLM generation, thanks to Gemini 1.5 Flash. And to evaluate those metrics for NER, we use precision, recall, and F1, the usual. For normalization, we use accuracy, F1, specifically relaxed match, and qualitative interpretability. And composite scoring, So for an optimal balance, we use semantic retrieval and lexical. The reason we use both of them, for example, I'll give you an example. In a clinical note, if it is ASA, if you look at the UMLS context, ASA could be aspirin, it could be American Society of Anesthesiologists, it could be atrial septic aneurysm, it could have multiple meanings. That's where lexical matching comes in and tells that no, ASA means aspirin. So that's why we use both semantic retrieval and lexical matching to give the right balance and to give it more context. And the results, so as you can see, the F1 score for our model, the fine-tuned BERT, outperforms the other out-of-the-box model. And what this tells us is that fine-tuning on a specific task, which we fine-tune on the two data sets, it outperforms models which we are just using it from Hugging Face. And on the right-hand side, as you can see, we use exact match and relaxed match. Relaxed match gives us a better accuracy than exact match because, for example, as I mentioned earlier from my example, in a clinical note, for example, ASA, if it compares with another clinical note, ASA might not find aspirin to be the exact match because it's looking at the exact thing. It's for relaxed match, it looks at the medical context. It knows that ASA is a shorthand for aspirin. And so you might think there is no need for a dictionary RAG normalization. We know how smart LLMs are, and there's a new LLM model almost every other week. So we did try directly asking the LLM, what is CKD? What is SOB? And in a lot of the cases, the LLM only using just Gemini, using just ChatGPT, they were able to give us the correct abbreviation. They were able to give us CKD as chronic kidney disease, SOB as shortness of breath. But in some cases, as you can see, TTE, just asking the LLM, it gave us echocardiogram, but the correct abbreviation should be transotheric echocardiogram. So that's the reason why, that's where the dictionary RAG normalization comes in, as it gives us more context, and it's further improved by RAG. So lastly, the conclusion. So our model, it converts the raw nodes into standardized, interpretable, and medical data. It introduces a dictionary RAG framework combining semantic retrieval with lexical re-ranking, which I explained earlier. It achieves high precision normalization through hybrid reasoning. It enhances the clinical interoperability across EHR system and global ontologies, and it provides an industry-ready explainable NLP pipeline for healthcare applications. So yeah, that's it from my side. Thank you so much.
Okay, great. Okay, so now I would love to get questions from the audience for our great speakers. Okay, great. Thank you. And we're going to use the mic so that those who are online can hear all questions.
Okay, my name is Lydia. This question is for Dr. Anand about the defects on wafers. The question is this technique target for blank wafers or for wafers process, being processed in the middle already?
So it's like this is actually inspired by a project that we did for LAM research. So what they were doing at that point was, it was a blank wafer, and they wanted to, I cannot explain all the details, but they wanted to detect if the wafer is there or not. What then? Okay, and so there was a robotic arm putting wafers in the chamber, but the robotic arm was breaking those wafers sometimes, and they had no idea about the broken wafers until it was the end of the process. So they were losing money. So they wanted a camera-based detection for the production so they can detect it sooner. But again, that's wafer, no wafer classification problem at that point. It was not in production at that point. The scratch also was happening during that time. But later we had, actually I presented another work last year in this RISC-IM5, which was for the wafers that we had the chips already on them. And what we were doing was there was the alignment to detect the errors for different layers that we were laying on those wafers. So I have examples for both situations. Yeah. Sure.
Thank you.
Hi, I am Professor Shubhankar Dhar from Information Systems and Technology. I am very much impressed by the project Spartan AI, and I would like to explore this further. I have a couple of questions. Number one, can you explain me the tech stack that you use to deploy this project, and how are you dealing with the hallucination problems that you may face when you are using LLMs? And the second question is, no, it's not a question. Is it possible to see a demo? Like, how is it working?
Okay, so for the tech stack, for the stack in the backend, we use the Python for our all the API orchestration, and for the front end, we use the Node.js. For the LLM, so LLM is running locally on the Azure Combat. So we are not using any third-party APIs, or we are not using Gemini, Claude, or OpenAI. So we are having our own local compute which runs our models. And to answer the question, like how do we prevent the hallucination? So for that, we use the retrieval augmented generation system, and we also use the meta prompting along with that retrieval augmented generation to prevent the hallucination, and to make sure that our model hasn't hallucinated. So we evaluated our project on the two of the early courses, and we found that it was accurate around like 96%. It was accurate on developing on providing the suggestion for suggestion for the improvements.
Why different? But why was rationale on the LLM choice instead of using OpenAI or Gemini? Why did you?
Yeah, that is because of like most of the faculties do not want to provide their courses to this third party, right? So because of the privacy concern that we chose to deploy our own LLMs on locally. And for the hallucination part, I think when we evaluated our two of the courses, so one of the courses is Professor Vincent's course, and we found that it was pretty much accurate for the evaluation, and it was ready for the to make available to the other professors. Do you want to?
Yeah, so for the second question about demos, we do have a live demo. Actually, we have a video recording for the demo. It lasts about 6-7 minutes long. So due to the time limit, we couldn't play it today. But if you're interested, we would be happy to share that with you. So the demo will show from the beginning how you export the course from Canvas, and to how to import the course to Spartan AI, and our analysis results. Yeah, so yeah, we can share with you.
Thank you. I think, thank you.
Bill, this question is for you. On the data center workforce. So sometimes we hear these, at least anecdotes about, the entire trades workforce of, a region, a small town, or a smaller state by population anyway, just being sucked up into one data center project, right? You can't get your HVAC system repaired because everybody who knows how to do that in Wyoming or whatever is working on a data center. So I wonder, kind of more broadly, right, zooming out from just that specific workforce, where do you hear kind of what are some of the critical bottlenecks? And just one other anecdote I hear from CBRE and some of those other real estate firms where they're offering services for managing data centers. Like, I wonder how many people in the world are actually trained and qualified to do that, and does that match the scale that's needed now or in the future?
Yeah, no, that's a great question. And the short answer is no, there's not enough. Not with the demand. Just right now, the demand is sky high, and you guys saw that the current data centers, 90% of them can't support the AI workload. So there's going to be a lot of building. Now, to answer your question more broadly, from a workforce standpoint, there's going to be the local workforce. Yes, in Wyoming, your exact anecdote. We have one that's going on in Tulsa, which is we're going to build this greenfield data center, and it's great. It's 70 miles west of Tulsa, but then it's like, how much workforce can we draw out of there? And maybe we're going to be drawing the HVAC guy into that data center instead of him working on homes. You know, and we're going to have that kind of shortage. But I think the majority of the workforce that's required is not in the data center, it's around the data center, the ecosystem to make it all work, right? And that in itself in every single layer. The one about manufacturing the chip defect, that was great. You did synthetic data and you solved that one problem, right? And that's going to be in the semiconductor space. But then just around, in and around the GPUs, I mean, there's already 7 layers of different workforces that's needed, right? So in that, it's incalculable. I haven't seen a stat that says, you know, what kind of jobs do we need in every single layer and how many more, you know, so it's something that we're all trying to figure out as an industry.
Thank you.
I have a question for you. So since you are working on these hardware infrastructure, so recently Google announced that they will be sending the TPUs to the orbit. So what do you think about that? How that will impact?
So it's not as crazy as it sounds. I had a project in 2015 where we were working with Boeing to do mid-Earth orbit satellites, right? Unless how do we make the satellite networks as a fly through, shoot a laser down to the data center and make that work? So in space is definitely possible. But when you take a look at like all the places where we could build a data center, I've seen underwater, in space, low Earth orbit, mid-Earth orbit, you know, whatever. Mars. I think I heard Mars once time, right? Great, low cooling, great, underwater, but how do you service them? And if you really like get into the nuts and bolts of a GPU, it's finicky. This is a Ferrari that breaks down a lot, okay? A lot. And if you talk to the Supermicro and HP guys that have to make it work, there's a lot of duct tape, not real duct tape, but analogous duct tape to make this thing work. So when we have a hiccup, and the AI, when AI workloads spike, it spikes in a millisecond, right? And all of a sudden your GPUs fail. Who's going to space? Like that, those are the kind of the bigger problems of maintenance and refresh. And by the way, the big money players like OpenAI, they're buying GPUs on a 3-year refresh cycle. So these B300s, these brand new Ferraris, millions of dollars, right? They're going to refresh this in 3 years because they're in an arms race. So who's going up the space for the replace, right? So those are the big questions about those remote areas.
I got a couple questions. One for the Spartan AI. I'm wondering how you handle drift in curriculum. I mean, I guess sometimes naturally the curriculum would drift, new topics would need to be introduced, things like that. And one question for Armin. From your presentation, it sounded like there wasn't any real data being used in the training. Is that, or do you augment the real data with the synthetic data, or is it purely synthetic data?
Okay. Can you repeat the question? I didn't understand. What do you mean by drift?
I mean, so what if the course topics or course syllabus naturally needs to change over time? It's because there's some new topic that needs to be covered in the course.
Okay, so to make sure that right now our workflow is like that. You export your course from the Canvas in the IMSCC format, and then you upload your exported course into our Spartan AI program project. So right now Spartan AI can handle 9+ file types. So it could be anything. It could handle JPEG, and recently we also introduced the support for the JPEG and PNG. So it doesn't matter like how many files, different files you have. We will it will process it, and every time your course get updated, you need to re-upload your courses for the re-evaluation.
Yeah. How does the evaluation work if it's
Yeah,
a new topic?
Yeah, I guess like if the course topic changes, our team is not trying to evaluate how what topics you teach in your course. We're trying to say if the topics you teach and the contents you have in your syllabus and also in assignments, in projects, they are aligned with QM rubrics. So the QM rubrics, they have many, how many? 14 rubrics, like to check if your, for example, course learning objectives can be mapped to certain assignments and certain projects. So we are primarily checking those kind of alignments and mapping, and we are not trying to tell faculty what topics you will need to teach. So if you change topics and if those topics, they can be aligned, they can be reflected in the new course, new assignments design, new projects, new homework, and then we can check if they are aligned with certain rubrics. Yeah. Hope that answers the question.
And I think Armin was going to talk about the data.
So the data was pure synthetic, and that was the goal of the research. We wanted to prove that if you don't have the data set, you can just count on this pure synthetic data to train models. And again, this was inspired by the project that we did for LAM research. So we asked them for data sets, and it took them kind of 3 months to give us 48 images. And it was a very time-consuming and expensive process because they had to connect some boards to the chambers to collect those data. And we came up with the idea that this is not going to work because we need thousands, not just 48 images. So we discussed that. We said that, okay, what kind of scenarios can happen during the production? And they provided us with a list of different scenarios. So we went to the virtual environment and started to just making those scenarios in virtual environment. But again, the critical part was if it's pure synthetic and perfect, your model is going to be overfit, you know? So you want to make it not perfect. How can you make a virtual environment not perfect? By importing randomness into that. So we started to come up with different sources of randomness that we can impose into the scene to make our data real world-like.
Thank you. We are at almost 12:15, so I do want to be very respectful of everyone's time, considering that the food is here. I want to thank all of our presenters. Let's give them all a great round of applause. I will ask the presenters to stay for just a moment so we can take a group photo. In the meantime, I'll go ahead and thank you all for joining us and say bon appetit. Thank you. And thank you everyone who is online joining us today virtually. We really appreciate your time. We appreciate you being here for our Research and Innovation Exchange series. Thank you.